State Newton's first law or law of inertia.
When an object remains in state of rest or uniform motion in straight line unless
Unless apply.
change
Apply what? Apply
force.
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 If you can't get the word compelled, you can just write apply. Apply an unbalanced force. Okay. So it's not necessary you have to write compelled itself. Compelled itself means forcing. So instead of that, you can change the statement applied. Clear? Okay. Gerlin, can you state the Newton's second law of momentum?
Newton's second law of motion states that the rate of change of momentum of an object is directly proportional to the applied force. To the applied force, unbalanced force is direction of force.
Yeah, applied unbalanced force. You can say at a stretch. Okay, unbalanced force in the direction of the force. Okay, good. Ashik, all of you on the videos. Bastin, Karthik, Sania Junu. Okay. Srihari, state Newton's third law.
And the total movement of the system.
Sorry, that is conservation law of momentum.
Third law.
Third law I just mentioned in between, conservation law of momentum. Do you remember? It's a very famous. I did not.
Reaction as
that's it. Okay. I did not teach you in detail, but everyone knows that for every action, there is an equal and opposite reaction. Okay. So, what is conservation law of momentum? Who else? Yeah, Sowell, can you say conservation of momentum, Sowell? Don't know. Huh? Okay, go to Abin. Go through your notes. Go through your notes, Sowell. Abin Thompson, what is conservation of momentum?
Total momentum of the system before collision is equal to total momentum after the collision, providing there are no eternal unbalanced forces acting on them.
Yes, correct. So, conservation of momentum says total momentum before collision is equal to total momentum after collision, provided there is no external unbalanced force. Actually, conservation of law of momentum, even the name is momentum, we are applying all these three laws in that. Okay, Newton's third law, first law, and second law. Okay, yeah. Revu, give me the definition of momentum. What is momentum?
Ma'am, it is the product of mass and velocity.
Yeah, it is a product of mass and velocity. Very good. What is the definition of inertia, Emerin? The definition of inertia.
It is an inherent property of a material change of rest or motion.
Yeah, to resist. To resist, that is more important, the word. To resist any change. Okay. Any change in state of motion, state of rest. Okay. Okay, children. So, we have completed conservation law of momentum. So, we go to little more detail regarding the Newton's third law. Okay. So, those who did not write Newton's third law, we can write the definition. So, Newton's third law, also known as another name, what we call law of impulse. Newton's third law, also known as law of impulse. First law we call it as law of, what is the name?
Inertia.
Yeah. Second law, what we call? Law of momentum. Okay. Inertia, momentum. Now, third law, we call it as law of impulse. So, we are moving on to impulse. Okay. So actually, what does the word mean by impulse? Impulse is the strongest force. Strongest force acting any type, either contact or non-contact. Strongest force acting in very short time. It is the strongest force which is acting in very short time. Strongest force. Yes, so well, can you, by understanding this word strongest force, can you guess any example for it? What do you mean by strongest force? The impact is too much, okay? Apart from accident, apart from collision, can you just guess any of the incident or action which is taking place within very short or fraction of time?
Ma'am, that
Which one? Apart from the collision of a car accident, that all. Think about some of the games, what you play, you all like to play. Just think about, is this impulse is there in that? Just think. Give me any games.
Ma'am, Pokemon.
Part?
Ma'am, Pokemon.
Walking more. Okay, very good. Anything else?
Ma'am, PUBG.
Yeah. I'm telling action, not the game. When you talk about game, you are thinking about the computer game. Is that? No, I'm asking any action, any game which you play, outdoor games. Think about any
Ma'am,
outdoor.
cricket.
Cricket. What is this? Yuvaraj is famous for what?
Football.
Ma'am, football.
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 Yeah, you all are only now you are in the world of PUBG and indoor games. So I'm talking about outdoor games.
Ma'am, also football world also.
Football, all the games. Okay, just think about Yuvraj Singh is famous for what actually in cricket?
Sixes.
Six. You see the impact of Yuvraj six. Actually, how much distance it covers if Yuvraj hit a six?
111 feet.
111. But there are people who hit Ricky Ponding and all. They will hit 186 meter also. You just imagine the impact.
187 is the highest six in the world.
What? How much?
186 is the highest.
186. Yeah. You must be wondering while you watch the cricket, as if Sachin Tendulkar, Virat Kohli, any one of the player, if they hit the six, as this ball is going, they will be showing the distance fast. Through computer, they will show it to what distance. Okay. Usually it is between 96 meter to 120 and all. But there are some huge sixers played by our cricketers and as well as outside cricketers also. Okay. Children, please on the video. Kshetra, Elsa and all. Elsa, I hardly see you in the class. Some of you say network, but some people purposefully switching off. That is very common in 9th, all the divisions, not only C, A, B, C. Yeah? So always a complaint is coming from your classes, 9 ABC. I'm not talking about 9C alone, 9 ABC or 3. You all are very active. I say 9C I didn't feel because maybe I know you very well. So you are active, but some other classes, they are not active. So that also is a problem. Okay, everyone should be interacting, then only they will understand. Okay, children. So another example of hitting a six. Okay, you see. Within short time, maybe you can talk about that touch, the contact between the ball and the bat is very minute, maybe the fraction of second. You can say fraction of second because the ball is coming 120 kilometer per hour. Some of the pace bowlers, Ishant Sharma and the famous, our Pakistani bowlers and all, the speed, the amount of speed they throw the ball, you see the impact is too much. Okay, so that is it's very short time. Another, similarly football, if you hit, if you kick, make a goal, you see the impact of it. Even including that entire, what you call, entire court will shook, no? That is the thing. Okay. Another one, can you talk about any other bad incident happen every now and then, Mumbai, everywhere? What is that? Can you anyone remember? Nowadays we are facing a lot there. Any bad incident happens in Mumbai, you know, many years, so many railway station has some bad incident and so many people killed. What was that? Lakshmi, anyone remember that incidents? Continues the 3-4 railway station Mumbai fully shook with some incident, bad incident. What is that? Common general knowledge is poor. Lakshmi, at nothing you are reading at home. I can see here. See, whenever I ask, no answer from you. Atulya, your general knowledge is very weak. Read newspaper sometimes, my dear girls. Don't simply sit at home, watch something and help in kitchen. It's okay, helping mother in kitchen, it's okay. But I'm talking about read newspapers at least. No, you are very zero in common knowledge. Adulya, I think you are uploading some videos and all, but in the class you are so soft. Why it's so? No active at all.
Ma'am, the
Huh?
today was some network problem.
That's okay. I'm talking about now Adulya. I'm asking Adulya.
Yes, ma'am.
Adulya, can you just remember some incident? There is at a time, many railway station has some problem in Mumbai many years back. What was that bad incident? So many people killed. Very poor. You all are not reading at what is happening around you, not even reading. Yeah. Bastin, can you tell? Arun Bhaskar, can you tell me? So many people killed. What was that?
Explosion.
Explosion of what?
Bomb.
Bomb. This is the point I am going on giving the clue. That's why I tell him general knowledge is poor. Bomb explosion is a clear example of an impulse, strongest force in very short time. Fraction of second, you can see the impact is this thing. So this has happened because of Newton's third law. Okay, law of impulse. So let us now go back to law of impulse in our daily life. So what is law of impulse? For every action, there is an equal reaction provided there are no external forces acting on it. Provided there is no external force, then only that equal and opposite action and reaction force will play. Okay. Another example regarding rocket launching. Srihari, can you explain the rocket launching once again? What is happening in the rocket launching?
Ma'am, when the fuel is burned, it will overcome the gravitational force and frictional force, thereby going to the space.
Okay. Then in that, can you tell me which is the action, which is the reaction in that rocket launching? Action and reaction, they are both are forces. One is one direction, another one is opposite direction. Can you tell me in the rocket launching? If you look at that picture, you remember the picture what I showed you in the slide? Yeah. So this is a rocket launching picture. Just look at. There are two things. There is an action,
because
there is a reaction. Yeah?
Ma'am, as it is producing a huge force, then it overcomes the gravitational force.
Okay. So, the movement of rocket forward, the forward movement of rocket, forward motion of rocket is an action. Okay. So, what is the our main motive? Rocket launching, in that what is action? We need to send the rocket in the space. So, forward motion of rocket is actually the action force. Okay. Then, you can see the expulsion of fuel. After the rocket moves, expulsion of fuel. That is in opposite direction. So, this is reaction force. Okay. So, forward motion, reaction force. Once these both come equal, and then the rocket will get a balanced act and it moves forward, and after some time one piece of this rocket will be fall down, and finally which is in the top, The capsule, we call it capsule of that is what which is launching in the space. So this is an example of Newton's third law. Okay. Yeah. So this is, we come to Newton's third law of motion. For every action, there is an equal and opposite reaction. Okay. So first important point is, for every action, there is an equal and opposite reaction. Second significance of that, there is a pair of forces acting on two objects. As we said, in the case of rocket launching, there are two objects. One is the rocket, another one is the fuel which is filled in it. So there is a force which is exerting on rocket. There is an equal and opposite force which is pulling backward. Similarly, a person is hitting a 6. The ball is exerting a force on the bat. At the same time, bat is exerting a force on the ball. So I'm asking to Karthik. Karthik. Karthik?
Yes, ma'am.
Yeah. Karthik, a person hitting a 6. In that, which is action force, which is the reaction force in that?
I'm hitting the ball is the action.
Hitting the ball is an action, okay. So who does the action force, ball or bat?
Bat.
Bat. So bat is doing action. Then what about the ball? Ball is doing
Reaction.
reaction force. Okay. Yeah. So this is what you need to identify, which is the action and reaction force. Okay. Now next, the third significance point is that size of the forces on the first object equals the size of force on the second object. So usually we will write it. Suppose the first object is F1, second object we write minus F2. That means why minus sign indicates it is in opposite direction. Okay, opposite direction of the first force. So reaction force always in the opposite direction of the first force. So usually we write F1 is equal to minus F2, or we can also write F12 is equal to minus F12. Minus F21. In the conservation of momentum derivation, we have done that. Okay, F21. So what do you mean by 1, 2? First object on second object, and F21 means second object on first object. So that is the third point. Same thing, same point repeated. Direction of the force on the first object is opposite to the direction of the force on the second object. So that is what I have mentioned to you. F1 is equal to minus F2. Okay, so that is the third point. Direction of the force on the first object, F12 is equal to minus F21. And same thing, they are in pairs, equal and opposite action and reaction. They are in pairs. Okay. So for every motion in the universe, or if you talk about every motion in the universe obeys all these three laws. You talk about a bird is flying. A bird is flying, same thing happens. You can see when the bird flap the wings, it is flapping the wings downward. It is flapping the wings downwards. That means it is flapping the air. It is pushing downward. The bird is pushing the air downward. Then the air in terms, it pushes the bird. Okay. That is why the bird has to go higher and higher and higher. Like that. Okay. Same thing happen aeroplane. Aeroplane also is made looking at the birds. Actually aeroplane, we are manufactured by looking at the birds. The human people thought, why can't we fly like a bird? In that thought only, actually the invention of planes started. So thinking that why can't we fly like a bird? So that is why we are using the bird's mannerism in an aeroplane. So you cannot see a plane in the cylindrical shape. We cannot see a plane in the circular shape. We can always see a plane in a particular shape with wings, 2 wings. Actually, when aeroplane moves upward, it pushes the air downward. Then air under the wings pushes the aeroplane upward. So it is a balanced act. It is a balanced act of engine, the external force what we give, and the force exerted by the air. Okay. So that is Newton's third law. Yeah. So children, I hope you all are understood. Anyone have any doubt regarding this chapter? Do you want me to explain the derivation or conservation law of momentum once again? We completed this chapter. So by this chapter, we completed laws, force and laws of motion. It has more theory, problems we are going to do. So already we have done 2-3 problems. And also I sent 5 problems in the WhatsApp. Those who did not get, I'll send it again. Printed notes, the notes what I send, you take the Xerox copy. You don't have to copy it in the ruled sheets. Suppose if you are aware, suppose your place is not a containment zone. If you are able to take the Xerox copy of the printed notes, you take it out. Okay, I don't compel you. Then after some time also you can take it. But the problems which I send in the WhatsApp, you need to copy down the ruled sheets. And it has to be kept with your printed notes. Okay, because this is we are going for internal assessment. So this year, your promotion majority, most probably your promotion will be based on your activities. Okay, you are writing the notes, doing the problem, and your performance in the class. That's why I tell you to open your mouth. See, there's a limitation for us to assess. So only way to assess your performance, your action, your active part in the online classes. Some are not even attending the class, I know. Some are video off, switch off purposefully.
Excuse me, ma'am.
Yeah. Some are having network problem, I know. I understand. I know the people who have network problem, but some are not doing purposefully. So this year your promotion purely based on your internal assessment. That depend upon our assessment on your behavior in the class, whether it's online or whatever. So don't think that. Don't think that. I know 5 to 10 students in this class purely active. So they will get more marks. That's what we will be we are thinking of giving it. Exam may be MCQ format. That is not the thing to correct assess you. So that is what I was telling you. Something we send in WhatsApp, do it. That's what I wanted you to. Okay. Printed notes I send. I don't tell you to write it on the ruled sheets. Take the Xerox copy. But problems, please write it down. In physics, in all the chapters, we have problems. So I will be giving you the problems. You need to copy it. Now, your term 1 activity. Your term 1 activity, what I was thinking of giving you, chapter. Go to your chapter, some parts. Next chapter, chapter 10. Chapter 10, page number 138 onwards. It's your self-study part. Page number 138. Chapter 10. That is gravitation. Next chapter, what we are moving on to. Gravitation chapter. Chapter 10, page number 138. Already we have learned in 8th standard, pressure. Okay. So, on the basis, we have a topic, thrust and pressure, Archimedes principle, density. So, refer that page number 138 onwards. Then, you have to write it regarding those things in A4 size sheet. So, that means I don't want you to only write from the textbook. I wanted the latest based on this buoyancy and Archimedes principle. So you can write it down the topics. I'll be sending in the WhatsApp also. So your activity this year, I mean term 1.
Is it like a summary of the?
Yeah, it's a summary. But I'll tell you what are the things I wanted. Okay. What are the things I wondered in that particular assignment, I'll be giving you the points. So your topic will be pressure. Pressure and latest inventions. Latest invention based on pressure. So you understood. Idea of pressure, you will get it from the textbook. But latest inventions, you can have at least 3. If at least 3, maybe some machines on the basis of pressure. Okay. Look, after 2000, what are the things that happened? Okay. Latest 3 means after 2000. After 2000, check in internet, latest invention based on pressure. After you just type year 2000, you may get. So at least 3 inventions I wanted. Just say what is that and give me one paragraph of each. Give me one paragraph. I just opened the e-board.
I'm from the year. Which year onwards we had to?
2000 onwards. Up 2000, after I just write an e-board, easy board, but because this is not clear. I opened the e-board, that is more easy to write. Once again, I'll give the heading, pressure and latest inventions. Pressure and latest inventions. We can have at least 3. At least 3 inventions after 2000. 1 paragraph each. Okay. We can have A4 size sheets. You can use A4 size sheets. Then, what are the contents I wanted? First, you should write definition of pressure. Definition of pressure. Then a new term you learn. Buoyant force. Buoyant force. So before writing the latest invention, you need to write about all these 3 points. Pressure, buoyant force, buoyancy, then Archimedes principle. Okay. We can refer the text for it. Refer text for it. Okay. After that, you can write the latest inventions. With the picture, okay? With the picture. Maybe you can draw or you can take... Saying something?
Ma'am, not clear.
Not clear. Which one not clear? What I am writing is not clear? First we will write definition of pressure, buoyant force, buoyancy, Archimedes principle. That you will get it from the textbook. Okay. Then latest inventions you should write after that. First 2-3 pages you can based on this. Next we can have latest invention with the picture or drawings, depend upon you. Okay.
Ma'am, your voice is not clear.
What? I can't hear you. You are saying something.
He's saying that your voice is breaking.
My voice is breaking. Maybe because I am shaking. Okay, once again I repeat. Pressure and latest inventions. At least 3 inventions you should write after 2000 based on pressure. Pressure and this buoyancy and buoyant force. Okay, anything which is related to pressure, you can do it. You can use A4 size sheets. Which are the contents I required? I have written here. Definition of pressure, buoyant force, buoyancy, Archimedes principle.
Ma'am, isn't Archimedes a Greek inventor?
Yes. Eureka. This is a story. Eureka, Eureka. He's not an inventor. Actually, he is a philosopher. Actually. But on those days, philosophers also will become a scientist because of their thinking. Okay. Next, latest inventions. After writing about buoyancy, buoyant forces, you can write latest inventions based on all these terms. It's not necessarily exactly pressure. You can write about the buoyancy, some invention. There's a lot of things happened in our life because of this. Okay. You can have pictures, images, drawings, photos, anything. Up to you. Up to your creativity. Okay. Then, fourth point, how many pages you should have? Fifth point, how many pages? Maximum you can have 10 sheets. Maximum you have 10 sheets. Minimum 6 sheets for submitting assignment. Minimum 6 means it should not be less than 6. Don't give me 3 pages and submit to me. I don't want, because 8th C I saw some of you last year. I don't know, some of you not even submitted, still I remember. But today, this year, no way. Internal assignment is more marks. Minimum 6 sheets. Then should have a covering, a beautiful covering page. Should have a beautiful covering page. With your name. Covering can be based on this. You can have something with your name and division. With your name and division. Okay. And send the photo of covering to me. Send the photo of covering personally in my WhatsApp. So those who submit only, those who send only, I'll give the marks. Send the photo covering personally in my number. My number 7560870313. So now today 14th, by next week, that by 21st. Okay, maybe I can give you 10 days, maybe up to 24th. Just think. I wanted all this. Some are very clever, only take the covering sheet and don't send me only that. I want the remaining sheets, keep it in a paper file for submission. Okay. Content we can have on submission. Okay, children. And rest of the things, I will be same things I can send in the WhatsApp also. Those who did not get, because your teacher is ready. Yo. Okay. So this is your term 1 activity. Your exam starts on month of September. So before that, I want all this by 24th. By 24th, I want all this. Okay. And my dear Maxi, Anthony, Maxi, Bastin, all of you, only make a covering sheet and then send it to me, telling that, ma'am, I complete assignment. No, don't do that. Okay. September, most probably October, you will see the school again. If God allows, you will see the doorsteps of your school again. Pray for that. Okay. I know you are bored at home. Better pray that you should come out from the classroom. Okay. Pray. Thank you.
Thank you, ma'am.